So, hello everyone, I'm Andrew, and today I want to continue this series of just talking about going over the specific concepts. And today I'll be talking about Unit 2, which is molecular and ionic compound structures and properties. So, this is the first topic, which is types of chemical bonds. So, as the objective states, it talks about the relationship between the types of bonding and the properties of elements of participating in a bond. So there are some factors that are important that you guys have to know, which will determine how and what types of chemical bond would happen. So the first one here talks about electronegativity values for the representative elements increase going left to right across a period and decrease going down the group. So these trends can be understood qualitatively through using the Coulomb's law. So this that, and then the valence electron share between similar electronegativity constitute a nonpolar covalent bond. And then vice versa would be the polar covalent bonds. And then the next concept is about how atom with higher electronegativity will develop a partial negative charge relative to the other atoms. And single bonds, greater differences in electricity negativity lead to greater bond dipoles, and how all polar bonds have some ionic characters, and the difference between ionic and covalent bond is not distinct, but rather a continuum. And then the next is about intermolecular forces and potential energy. So intermolecular force is usually shortened as IMF, and this is a great, I guess, shortened term that is good to know for the AP exam. So this is about representing the relationship between the potential energy and distance between atoms based on factors that influence the interaction strength. That's the main objective, and the specific information states that the graph of potential energy versus the distance between atoms is a useful representation for describing the interactions between atoms. Such graphs illustrate both the equilibrium, bond length, and the bond energy. So we'll be looking through this graph more specific, but it is sort of self-explanatory on terms of what it says. And then the next concept is in a covalent bond, the bond length is influenced by both size and the atom's core and the bond order, single, double, triple. And as the bond increases from single to triple, then their bond energies will be greater, but then their bond length would decrease accordingly. And then it talks about Coulomb's law using to understand strength of interactions. So this is all connected to Coulomb's law that we'll be talking about a little later. And then it's the structure of ionic solids, and the objective states that it is to represent an ionic solid that is a particulate model that is consistent with the Coulomb's law. So as you guys see, you guys would see this trend where every single thing we go through, there's this thing called Coulomb's law, Coulomb's law. So if you guys look at the Coulomb's law from last time, you guys would know that it's, I guess, it's composed of a certain formula. But the thing is, in AP Chem, you won't have to calculate using the formula, but then you would just know it as a concept where if this value increases, this would decrease accordingly, and et cetera, et cetera. And in this one, it'll be talking about the cations and the anions arranged in a systematic periodic 3D array that maximizes the attractive forces among cations. So they're not that important, but you still would have to know about it. And this is about metallic solids and alloy. This is also not that important on the AP exam, but it will still come out accordingly. And it is about metallic solids and their essential characteristics in terms of their structures. And some important things you would have to know is about metallic bond, how it is about a positive metal ion surrounded by delocated valence electrons. And this really important key term is sea of electrons, especially when you're doing an FRQ, because every time the FRQ talks about describe a metallic solid, if you just write sea of electrons, then you would at least get a point of doing so. This is really important when it comes to this concept. And this is about interstitial alloys and substitutional alloys. So those are two types of alloys, and they will mostly come out in an MCQ and not that much in an FRQ. So interstitial alloys form between atoms of different radius, where smaller atoms would fill the interstitial spaces between the larger ones. And then the substitutional ones form between atoms of comparable radius, basically the similar ones, where one substitutes for others in the lattice. And then the next is the Lewis diagrams, or in other words, Lewis structures. I'll be going over how to draw this later on, but this is really important as you would do it in general chem, and in AP Chem it's basically the same thing, but it's just that in an FRQ you would know how to draw specific hard examples, and in the MCQ they would make you to compare what is the correct way to draw it. So it's easy and fundamental, but the thing is they sometimes do make it confusing, so they're really important to know. And then is also resonance structures and formal charges. You would also go through this in general chem, but just for a review, where resonance structures are basically a structure in which when you would have a double or a triple bond, you would just make it so that if it were to form a resonance or like a proportion, you would give the double bond to other dimensions such that it represents every single possible scenarios. And then it talks about octet and the formal charge calculations, which we'll be going through later, but basically you would subtract the number of bonds with the lines to come up with a formal charge, and you would have to write it in an FRQ and also determine what is the more fitting structure. And in this case, it would be a atom or the element with the less formal charge possible, or anything with +0. And then is the VSEPR and bond hybridization. So this is pretty important, where you guys would probably also do it in general chem, where the thing in AP Chem and General Chem is that in the General Chem, when you guys take a VSEPR test and hybridization test, the teacher would usually give you this sheet. I don't know if it has changed over the past few years, but when I did at the very least, we were given a chart of basically various VSEPR structures, and we'd have to match it according to the different compounds. And you would know if you've seen the chart before, there's a lot of scenarios and you have to know a lot. But the thing in this and what we've done in the past in AP Chem, you have to memorize every single thing. So for example, if it's a linear structure or if it's a seesaw, you would have to know everything, how it looks like, and how to apply them without the chart. Same with hybridization. So this also comes out really a lot, and to be honest, there's no other tip than memorizing, so they're really important. Yeah, so here it talks about molecular geography and bond angles, and those are some various factors when it comes to Lewis structures and VSEPR. And to be fair, or to be honest, you have to memorize bond angles, geometry, and everything, so there's no other solution. And then hybridization is sp2, sp3, and those kind of things you could see along the VSEPR chart. And if I could give you guys a tip, they don't go into the D's. So if it's so the maximum I've seen is sp3 structures. Just memorize your VSEPR chart according to and just accommodate it with the hybridization just until sp3, because beyond that it's not going to come out because it's way too complicated and various scenarios would come out. And this is it for this video, and next time I'll be going over Unit 3.